Morning to all of you. Parin, tell me what is the equation for magnifying power of simple microscope when the image is formed at least distance or distinct division?
M is equal to 1 plus d by f.
What is D stands for?
D stands for the least distance of distinct division.
Least distance of distinct division. What is its value?
25 centimeters.
Okay. Next is magnifying power of simple microscope when the image is formed at infinity. That is called normal adjustment. So last class we have seen one part of the diagram. Taking the diagram. Object is kept at the focus. One focal length away. Where passing object center goes without any deviation. Another one parallel reflection of the reflection. Passing and both are parallel. Your eye is held close to your eye is held close to the lens. Image from that infinity. So highly magnified real inverted image is formed at infinity, and which is very comfortable for observing. So real inverted highly magnified image is formed at infinity, and you are defining magnifying power is m is equal to magnifying power is m equal to beta by r. That is angle subtended by image at I at optical center. That is this angle. The angle beta. This is the line which is made at the point here. Beta is marked. So the angle subtended by the object when the object is at least distance for distinct division. Okay. Is not marked here, so that we have to mark in the diagram. Okay, we have to mark in the diagram separately. Object is placed AB at least distance for distinct division, and your eye. And what the angle it makes with the eye by the object at least distance for distinct division, that is R. This diagram we have to do separately. So beta already marked in the first diagram. Object at infinity. And next one, object should be at least distance of distinct division to the eye, that is angle subtended by the object with eye when the object is at least distance of. So this is equal to, from here you can take it as alpha beta small, tan beta can be calculated as equal to tan beta is AB divided by C divided by, in this case is alpha equal to AB divided by B directly. So AB cancels. AB you are cancelling. The remaining is B upon CB. What is C stands for? B stands for focal length. So M equal to by. So this is the magnifying power in the normal adjustment equal to this is equal to magnifying power equal to. If you are using a convex lens of focal length 5 centimeter, then magnification will be equal to magnifying power will be equal to 5 in this case. But it is very comfortable for eye to observe the image. Maximum value is always formed when the image is formed at least distance or distinct division. Its value equal to case 1 we are seeing magnifying power equal to 1 plus df when the image is formed at least distance or distinct division, and this is maximum value. And minimum value will be equal to d by f when it is image is formed at infinity. These are the general conditions for all. So simple microscope is the basic of other instruments. There are two cases here when the image is formed at infinity and that is normal adjustment. It is d by f, 1 less. Maximum value, if I am using f equal to 5, what is the maximum and minimum value of magnifying power of a simple microscope? Maximum value is equal to 1 plus 5, that is 6. Minimum value equal to 5. So only one ka difference hai, but which is comfortable, that is the second case normal adjustment. Okay, next we are going to compound microscope, which is very important if you want to get again magnified form, highly magnified images of the object you have to get. Then we have to use compound microscope, which is very important. So simple microscope is having only one lens, and compound microscope we have to use two lenses we have to use. So two lens arrangements. Next is compound microscope. Very important compound microscope. So compound microscope is used to get highly magnified images of very small objects. There are two lenses. Compound microscope. There are two lenses here. Convex lenses. First lens, which is facing toward objects, we call it as objective lens. And second lens, we call it as eye lens. Or we call it as eye. So compound microscope is used to get extremely highly magnified image of very small object, and so two lenses called convex lenses. So two convex lenses. And first lens, which is close to the objects, okay, that is called objective lens O. And another one is eye lens or eyepiece, which we observe. And some speciality of the focal length and size. Focal length and size. Objective lens of very small focal length and aperture is small, and whereas the eyepiece is of moderate focal length and large aperture. Objective lens specialties, focal length is very less and aperture is size. That is very less. Focal length of objective lens minus f naught should be very small and aperture is very less. And second one, eyepiece of moderate size, aperture little more bigger. Aperture is greater than that of this one, and FE of eye lens, that is moderate value. Moderate value, not very large value. So we are going to see the construction of objective lens and eye lens. Objective lens ka size is less and focal length is very small. That is a very important point you have to remember. And eye lens size is comparatively bigger than that of objective lens and is on moderate. There are two cases of image formation. First one, when the image is formed at least distance or distinct division from the eye is held very close to the eye line. Second case, final image is formed at infinity. So case one, image formation. Image is at least distance of distinct division. Image is formed at least distance of distinct division. First case. So two lenses, one is of short focal length, we call it as objective lens, and focal length is f0. So that faces the object. Second one is your eye lens size, because bigger and aperture is more than the and moderate. They have common principal axis. They are fitted at the ends of two coaxial tubes which can be moved to and fro. The distance between them can be arranged. This is fitted at one end of one tube. This is also another end of another tube. And both tubes can move along the coaxial. So it's a polo tube. So this is the principal focus of objective lens. Where is the object? Object is very, very close to the focus, just beyond the focus of object. Object is just beyond the focus of an objective lens. Where will be the image formed in this case? Anyone? Anyone? What is the image? Where will be the image? Natural image.
Beyond 2f.
Loudly, please.
Sir, beyond 2f.
Okay, the object is here between F0 and 2 F0. If you want to get mark here, 2 F0, you mark it. So the image will be formed rear inverted. Magnified image is formed beyond 2 F0. So one ray passing through optic center without inclination. Another ray parallel to the axis. After refraction passes through the focus. And both are going to be at this point. This is F0 and here I am at 2F0. So rear inverted magnified image that is formed beyond 2F0 of objective lens. Both lenses will form its own image, so magnification will increase. So first thing is that object is placed just beyond F0. Its real inverted magnified image is formed beyond 2 F0. Now what we will do? So the image formed by this first lens, objective lens, A dash, B dash will act as the object for eye lens. Now eye lens will act as simple microscope. So what we will do? Adjust the distance of eye lens so that A dash, B dash, this object will be lying between its optical center and principal focus. C1 I am marking for the optical center of the first lens, C2 I am marking for second lens. So what we are doing in this arrangement, adjust the lens, eye lens so that A dash, B dash will be between its optical center and principal focus. So I am marking the principal focus FE. So object now it is between optical center and the focus, and you know where will be the image formed. So when an object is between optical center and the focus, you will get virtual, erect, and highly magnified images formed on the same side of the object. So for that, we make one ray. This another ray passing through optic center. Then the second ray from here it goes passing through focus and goes focus. And your eye is held with eye lens. And for somebody is from here observing, these two rays are not at all meeting here. Appear to come from the same side. Virtual image is formed. Extend them back. You can extend. So they are extending back and they are meeting here. So we are getting the image at this point. This image is A double dash and B double dash. This image is formed at least distance of distinct vision. Here you can mark. Image is formed at least distance of distinct vision from the eye. So you can move this eye lens to and fro so that the clear image is obtained at least distance or distinct vision. So now find A double dash. Here is A double dash. A double dash, B double dash is coming down. They are meeting here. So we are getting the final. So this is the most important diagram. So case 1, image is formed at least distance of distinct vision. In this case, how you define magnifying? Magnifying power, you are defined this. Magnifying power ordinates defined as theta by alpha is angular magnification. It is angular magnification. Angle subtended by the image divided by angle subtended by the object. But locations of the image and object are very important. So here the image is formed at least distance or distinction. I am going to define this. So this is defined as the angle subtended at the eye or eye lens by the image and angle subtended by the object at the eye when both the final image and the object are at least distance or distinct division. Okay. So here is beta by alpha. Image is already at least distance or distinct division. And the object has to be also at the same least distance or distinct division, then only you can see the object. So object now is not at least distance or distinct division, only image is there. So it is the ratio of the angle subtended by the image to the angle subtended by the object when both are at least distance or distinct division. So you can see that image is already there on at least distance or distinct division. And what the angle it makes here, you can see that the angle is coming down. So at this point, I am marking the angle beta. This is the angle beta. Angle beta is figure triangle C2, A double dash, and beta. So the big triangle is forming a big triangle. Next point. Object also should be at least distance or distinct. Object is AB, but what else I know? You have to shift this AB object. You have to move this object AB to at this position. So I have moving objects. This is your object position AB. Notice you have to move the object here to the point I mark here A1, not A. So object also should be at least distance or distinct. From here, let the object makes an angle. So draw a line for center. From here, we have to draw a line. This angle is alpha. So alpha beta, they are marked at the optical center of eyelids, and your eyes are very close to the eyelid. Now, what is beta by alpha can be calculated from tan alpha and tan beta. So tan beta is taken from the triangle. So I am writing here. Tan beta from this triangle is A double dash B double dash divided by its horizontal side, that is C double dash. Divided by. What is tan alpha? Look at the tan alpha is this angle. It is A1 B double dash. A1 B double dash divided by again side is horizontal side is C2 B double dash cancel the horizontal side, and we are getting magnifying power. That is M equal to A double dash divided B double dash divided by A1 B double dash. A1 B double dash is same as the height of the object. There is no change. So M equal to A double dash B double dash divided by you can write it as A. This is the first equation we are getting. Final image. That is the second image. A double dash B double dash. Final image is inverted with respect to the object. So A double dash B double dash upon AB. So A double dash B the final image and AB is the starting object. So each may one more image is formed. What is that? A dash B dash. So multiply and divide with A dash B dash. The equation is taken to M equal to A double dash B double dash divided by A dash B dash dividing the A dash B dash. A dash B dash divided by. Now we are getting two equations. Now tell me what about this and what is this? A dash B dash upon AB. AB the object of objective lens. A dash B dash is its image. Image of objective lens divided by object of objective lens. This is the magnifying power of first lens, that is objective lens. This I am writing it as magnifying power of objective. What is this A double dash B double dash? This is the final image formed by eye lens, and A dash B dash will act as the object for eye lens. So this is for eye lens image divided by eye lens object, or magnification of eye lens. So M means we are getting two equations here. So magnifying power is 1 by. Magnifying power is only 1 by this equation. M equal to ME into M product of 2. So magnification is increased. The total magnifying power is the product of magnification produced by eye lens and objective lens. Now, what about eye lens? Image is formed at least distance or distinct division. It is a simple microscope. So here I am writing this equation as number 2. But magnification of the eye lens is 1 plus d by f. The simple microscope is just write E stands for eye lens. 1 plus d by f usually write. Now we are writing here fe. Fe because it is the focal length of eye. Eye lens acts as a simple microscope. It is formed at this distance. Okay. Now what about MO? Magnification of objective lens. Magnification of objective lens. Magnification of objective lens is A dash B dash upon AB. This can be related to their object and image distance. That we have seen in the case of lenses, ordinary magnification, A dash B dash upon AB distance. So this will be considered as image distance upon object distance. Image distance upon object distance. We consider this. So this will be equal to C1 B dash. From here C1 B dash divided by AB. Side can be written as C1B. That means image distance upon object distance. We can convert this into image distance upon object distance. Ratio of the vertical side is equal to ratio of the right. Angles are similar. So this is equal to, so that is MO equal to, MO equal to C1B. It is on right side plus C0. Image distance of the object by the objective lens. And C1B object distance that is on left side, we take it as minus C0. Minus U. So two equations are formed here separately. Substitute in equation number 2, plot and magnifying power is as like this. 1 plus d by f into b naught upon minus b naught. Minus sign means that the final image is inverted with respect to objects. Final image is inverted with respect to the meaning of minus sign. So this is the magnifying power, that is m equal to putting on the top magnifying power of composite and the image is formed and this division is m equal to first we are writing b naught upon minus a naught into 1 plus d by f. So u naught object is just beyond the focus. That may be given to you. V naught you can calculate by knowing the focal length. Now, as a special case, what I am going to say, the special case. Object AB is we are saying that it's very close to F naught. So, object AB is very close to F naught. So, what we can write as U naught can be taken as what is the focal length of objective lens. So, U naught can be taken as F. This AB is very close to F naught. Object distance of the objective lens can be taken as 6. And the image by objective lens A dash B dash is very close to eye lens. And A dash B dash is very close to eye lens. So, what the object image distance? Image distance can be taken as, that means distance between objective lens and eye lens. That we call it as the length of microscope. Object is very close to the focus of objective lens, hence U naught can be taken as F naught. And the image formed by objective lens A dash B dash is very close to the eye lens. So the distance between objective lens and eye lens is taken as V naught, that is the length of your compound microscope. So this means we are writing another form as a special. This is the general equation. M equal to instead of V naught I write L divided by F naught into 1 plus V by F. Minus sign shows that final images is inverted with respect to. This will be like numerical magnitude as M equal to N upon minus f naught modulus 1 plus b by dt. What are the different ways of increasing the magnifying power of a compound microscope? You can see that f naught should be small. Okay, first important point is that f naught. That is why we are taking objective lens of short focal length. Why it is necessary to use an objective lens of short focal length in the compound microscope? Reason A, it is in the denominator. So denominator f naught, if it is decreasing, magnifying power can be increased. And B cannot change, is remaining constant. Fe is not very large, but it's a moderate value, that is also less. So by decreasing f naught and keeping moderate value of I lens focal length, we can increase the magnifying power of compound microscope. Now next point in this is compound microscope in the normal adjustment. Compound microscope in the normal adjustment, exactly same way a small change will be there in the diagram. Okay, when the image is formed, final image is formed at infinity. Okay, what will be the pattern of the diagram? So this is most when the image is formed, final image is formed at infinity. That's the diagram you have to. Exactly same object is placed just beyond the focus AB and real inverted image as B dash is formed beyond 2f. What we are to do now, adjust the island so that B dash will be at the focus. So at the focus I am marking here. So this point will be now at the focus. So A dash B dash will be at the focus of island. So image will be formed at infinity. So two rays I am changing, everything is particular. This ray will go like this ray, I will take and go like this. And these two rays are parallel. Okay, these two rays are parallel. So final image will be formed at infinity. So extend them. Rays are parallel and final image at infinity. A double dash, B double dash will be at infinity. So this is the diagram for the slide change. Same part is here, and A dash, B dash now you have to be at the focus. First focus you have to be here, and these two rays will change final image format. So all of you complete this diagram, and we have to see what is the magnifying power in this. Again beta by alpha, but there will be slight change in the definition of it. All of you complete the diagram. So again, magnifying power in this case, m equal to beta by alpha. But here image is at infinity, but the object is not at infinity. So it is the angle subtended by the final image at I when it is infinity to the angle subtended by the object when it is at least distance or distinct. So for object, you have to make a separate diagram and you have to combine the results and we'll write the final equation. So that equation will continue next class. Thank you.